Bismillah ar-Rahman ar-Rahim. Statistics for data science. In this part, we will discuss measures of dispersion. There are different types of measures of dispersion. In this lecture, we will explore the one of the common measure of dispersion called range. So, what is measure of dispersion? A measure of dispersion is a statistical value that describes how spread out a set of data is. Measure of dispersion shows how much individual items vary from each other, helps identify variation in data, how consistent the data is. Small value signifies more consistent data, and a large value indicating greater variability or inconsistency. If dispersion is low, it means that the data points are packed closely. Here is a normal curve with different spread, low dispersion. Here is medium dispersion and high dispersion. When there is a great variability in the data set, so it means it has a higher dispersion. Here is a graph of consistent and inconsistent data. In the consistent data, dispersion is low and values are near to each another. Inconsistent data, there is great variability in the data set. So, low dispersion means performance is consistent, where high dispersion means it is unpredictable and there is inconsistency. For example, if the delivery time, if we calculate the range of the delivery time and it is small, so it means that the service is reliable. It is punctual service. Application show how much data fluctuates, helps in decision making, stock market risks, disease spread, important for forecasting and predictive modeling. Low dispersion mean consistency, confidence, predictable, better decision. Uh, we will be able to make a better decision when there is a low dispersion in the data set. High dispersion mean uncertainty, risk, unpredictable, risky decisions. There are different types of measures of dispersion. Here are some common list of some common measures. But in this video, we will explore the first one, range. A range is a difference between maximum and minimum value of the data sets. It gives us a quick review of the spread. Simple but affected by outliers. And it is absolute measures, uh, which is expressed in the same unit as of the data. A range here is a data set with maximum and minimum value. So range is 17 and there is another data in which range is 6. So in the first data, dispersion is high, where in the second data, dispersion is low. So the values are more consistent in the second data set. So in this way, we can calculate the range by calculating the difference between high and low value. Here is an example of exam scores of top 10 students. Midterm exam scores in which range is 14.7 and here is terminal scores in which range is 7. So terminal exam score are more consistent and less dispersed as compared to the midterm exam. Students perform more uniformly in the terminal exam compared to the midterm exam. So higher dispersion in the midterm suggests that some students perform much better or worse than others. So for future decision making, and forecasting. Terminal score are more reliable for assessing overall student performance. Here is a Python implementation, so we can simply use the built-in Python built-in function max and minimum to calculate the range of the data set. So here we have a data set of the midterm and final term scores. Now to calculate the range, for example, uh, range of the midterm will be equal to maximum value of the uh, midterm minus minimum value of the midterm. Similarly, range of uh, terminal, for example, will be equal to maximum value of the terminal score, final terminal score, final term minus minimum value of the final term. Now print range यानी mid term is equal to range mid, and similarly to print the range final, so we'll get here range terminal. So here is a range for the midterm. For midterm, dispersion is value is 14.7, while for the final is 7. So uh, this higher dispersion in meter suggests that some students perform much better or worse than others. So uh, the score of the final term is more consistent than the midterm. So we can use the final term score for forecasting